Here's a statistics question, and bear with me if it's a little bit blurry here, but I'll do my best to read it. It says a city believes that it should raise the speed limit on a local road from 25 miles per hour to 35 miles per hour. Using a car speed detector, I guess a radar gun, something, a random sample of 32 car speeds was selected. From the sample, the mean speed was found to be 31.2, trust me, with a standard deviation of 3.6. Calculate a 95% confidence interval for the true mean speed of all cars that travel this road. Assume the conditions for inference are met. Now, this gives, I've got the sample mean, which is 31.2. I got the sample standard deviation, which is 3.6, but I don't have the population standard deviation. So I'm going to use a t-test here. And here's the formulas. I've already written them down for simplicity's sake, so I can just show them. And hold on, I've got to be able to get scrolled over to that. Nothing's ever simple with me. All right, n is the sample size, is 32. Here, I'll do my ciphering in red. N is 32. The degrees of freedom is the sample size minus 1 is 31. The sample mean is 31.2. The sample standard deviation is 3.6. Now, I have to find the confidence interval, which is going to be the sample mean plus or minus the margin of error. How is the margin of error calculated? The margin of error is the t-score, or the critical t-value rather, times the standard error. How is a standard error calculated? Standard area is the sample standard deviation divided by the square root of the sample size. I'm going to need this value to find the t-score. I need the alpha value. If it's 95%, then the alpha value is, it's what's in the tail above and what's in the tail below. Here's the distribution, 95%. I'll just put 0.95. I want to know what's in this part and what's in that part. Well, it's 1 minus 0.95, which is 0.05, but each one of those is half of it, so it's 0.025 and 0.025. And so the alpha is 0.5, but to find the critical value for t, I need to take that 95 plus alpha over 2, because I want this part. I want everything that's below this upper tail for a two-tail test. So this is 0.95 plus alpha divided by 2 is 0.95 plus 0.025 is 0.975. So now I can calculate the t-value and start calculating all of this stuff. Well, first let me calculate the standard error. Standard error is the standard deviation of the sample, 3.6, divided by the square root of the sample size, which is 32. You can write a number down and round it off. I'm going to use that for standard error exactly, but it'll come out to a value. 3.6 over square root of 32, whatever that is, but I'm just using that exactly. Now I'm going to find the t-score, because I'm going to need to multiply that standard error by the t-score. To get the t-score, I'm going to go to my TI-84 calculator, and I'm going to go to second, vars, which is distribution types, and I'm going to go down to inverse t. And all I have to do is enter that area. And again, I want the area that's 95% plus the left tail. So 95 plus alpha over 2, 95 plus 0.025, 0.975. It's already entered there. I want the degrees of freedom. N minus 1, n is 32. Degrees of freedom is 32 minus 1 is 1. And then I will paste it. You have to press paste and then enter again, and it gives you the value 2.0395. I can use that whole value, but I'm just going to put my critical t equals 2.0395. 2.0395. Okay, now I need my margin of error. Margin of error is that t-score, 2.0395, times my standard error, which is 3.6 over square root of 32. And that equals, I'm going to do 2.03 395 times 3.6 divided by, where is square root on this thing? Square root 32, and that comes out to 1.29799. I'm going to just round that to 1.298, approximately 1.298. You can use that whole number if you want to get more exact, but this is multiple choice, so I'll be able to find it. So now, my confidence interval is the sample mean, which was sample mean plus margin of error. Sample mean is 31.2 plus or minus this 1.298. So I'll do that, 31.2 plus 1.298, and that comes out to 32.498. And let me look at the answer choices here. 32.498, 32.498. That's the high value. It looks like B is the answer, 32.498. And then I'll subtract it. So this is 32.498 is the high value. And then the low value is 31.2 minus 1.298 approximately. And that comes out to 29.902. That's the lower value. And so that does, in fact, 29.902 to 32.498. That's answer B. So if you need to look at it again, watch the video again. Watch it in slow motion, and I'll sound like this. Or watch it in fast motion. If you think you've got it, you just need a refresher. Watch it, and the whole thing will sound like this, and then I get the answer. But the answer is B, and that's how you determine the confidence interval.